Once upon a lab, there were two sunflowers. One sunflower was the envy of the lab. Stephen was the most beautiful flower that any scientist had ever seen. The other sunflower, Cinderella, was not so beautiful during the day. She was bullied by others for not being as good as them. But none of them knew that she had a secret, the power of fluorescence. They say you are not so bright. You shouldn't be called a sunflower with how dull you look.
Why are you being so mean to me? Maybe you're the one who is not so bright for saying such awful things to someone you don't even know.
Whatever, loser. I'm pretty and you're not. I absorb light, which makes me the brightest and most beautiful sunflower in this lab. What's wrong with you that makes you so ugly?
The researchers genetically modify me. I don't look so bright in the daylight, but at night, I shine brighter than even your future.
That can't be possible. How?
It's a scientific phenomenon that is happening on an atomic level. I wouldn't expect you to understand such complex physical concepts. It's all possible because of my electrons.
That doesn't make any sense. Electrons. That's some bull. Hey, say that to my face, you limp noodle. Hello, y'all. I'm an electron in Cindy's body, and I'm going to explain the science behind absorbance and fluorescence, which makes Cindy secretly bright and beautiful in the dark. So let's talk about Stephen. Just like any regular plant, he absorbs the sunlight and transfers it into energy. The cells in the leaves of any regular plant are able to undergo a process called photosynthesis. That is when a small part of the cell, called a chloroplast, absorbs the sunlight photons, thus excites the electrons with energy. At that point, an electron is too powerful to stay on the ground level and jumps higher and higher to what is called an excited state. Eventually, the energy may be lost in a few forms: heat, photochemistry, which is later on energy, and fluorescence. That is why Cindy is able to shine in the dark. Her electrons lose the energy in the shape of visible light, which is so pleasing to the eye. In the lab, we can use the following equations to find the lifetime of a fluorescent chemical. For that, we need the rate constants of fluorescence, K sub F, non-radiative dissipation K sub Nr, and energy transfer K sub T. After we have the values, we just plug them into this equation. And voila! Also, we can determine the fluorescence quantum yield, which predicts how likely the electrons are to lose their energy as fluorescence, instead of any other way. We need all the same values, but we plug them into a different equation. I think I am done explaining for now. Kids, use this information wisely, and go do your homework. Well, what's the point of you glowing at night if all of us are asleep and can't even see it?
Beauty is not just to be expressed as looks. I always have it within me. It takes the right kind of flower to be able to spot it. Just you wait and see.
6.5 hours later.
Hey Cindy, where are you? Whoa. You really do shine at night. I wish I could have been able to see you like this sooner. Maybe I wouldn't have bullied you back then.
It shouldn't matter if you know I'm not as ugly as I look in the daylight. I'm a sunflower, the same as you. Everyone deserves to be treated kindly no matter how they look, including me.
Meanwhile.
I'm so high right now.
Later.
Oh, there's Cindy. You're so ugly, you make our lab look bad.
You're the dullest plant I've ever seen. Why do you even exist? You're a lab freak.
Hey, STF you guys. Stop talking about Cindy like that. She might not be the brightest now, but at the right time, she will take your breath away. Just like that, Stephen started caring for Cinderella. He was the only one who knew her true side. Eventually, they intertwined stems and combined their sex cells to produce offspring. And they lived happily ever after.